Okay, are you able to see my screen? Someone to confirm? Okay. Okay, who can maybe who can give us the definition of machine learning before even I get into it? Can we have someone uh, to tell us what is machine learning? What is your understanding when you hear machine learning? What do you understand by machine learning? Maybe someone can just tell us. Amos, what do you think machine learning is?
For me, like I can't recall, like sikumbuki. So,
You can't remember anything. Not even the definition, but how do you think machine learning works? But you are blank when it comes to ML. Someone else? Uh, Kezia, what do you think machine learning is? You guys are not willing to talk. Rodovan, you can just give us a brief of what you think machine learning is. Tuuze bidhaa, what do you think machine learning is?
so for me, I think machine learning is the development of a computer system by using algorithms and statistical models to analyze and draw inferences from patterns in data.
Mhm.
I guess something like that.
Uh, I think that one is a good. It's a good definition. It's a creating algorithms that are able to derive inferences from data. Mombi, what do you think machine learning is? By the way, for your information, I just want us to have a discussion around this before we start the implementation of machine learning. That is on Monday. This one is a discussion, just a discussion. It's an open discussion around the machine learning. Mombi, do you have any? How do you think machine learning works? Joseph, just an open discussion. Okay, let's stop with the machines. Okay,
So,
how do human? Okay, yeah, Joseph, continue.
according to me, machine learning is a field of artificial intelligence that
Yeah,
enables systems to learn and improve from data without explicit programming
yeah.
or using algorithms to analyze data.
I think that one is now a perfect. That one is now a perfect definition of machine learning. But even before we get to machine learning, how do human being learn? How do you yourself learn? maybe I think we should start from that point. How do human being learn? How do you learn new concepts?
Uh, okay. I just believe, okay, depending, it's okay.
Yeah.
It depends on maybe where someone is, because like if you check traditionally,
Yeah.
people could learn either from seeing, from getting in touch of this products or the features.
Yeah.
And now, for example, now for us, like we are interacting with information. Let's say, for example, we are reading something which was written before,
Yes.
kind of
That is just now one way. Reading, you can read, right? You can read uh, you can read articles. You can read comments from social media, right? You can read books. And another way to learn is through you can learn through what maybe for human you can learn by observing, right? There are so many ways in which human being can learn. You can also learn by listening, right? There are so many ways in which human being learn. Maybe interacting with you can learn by the interacting with others. So meaning that there are so many ways in which human being can learn. So now when we come to machine learning, the machine learning is limited the way it learns, because it can only learn from data. And that is why we are saying that in the real world, we are surrounded by human beings who can learn everything from their experiences with their learning capability. And we have computers on machine which work on instructions, right? But what we have been doing, that is the basic programming we have done with Python, is just by the way we have been interacting with uh, the machines is through giving it instruction, like giving it an instruction to print something, like giving it an instruction to do a certain computation, right? That is now what we call an explicit. It's an explicit program. It's explicit programming. It's kind of you are giving you are not like you are giving instruction to a computer to carry out some operations. That is giving a computer operation on to do a certain computation, uh, to do a certain let's say maybe a certain task, like the one we just did with the ADA. In fact, we were just passing some instruction to the computer, and then we get the output. So that one is an explicit. That one is explicit programming. But we're asking ourselves here, but can a machine also learn from experiences or past data like human being does? Yes, it can nowadays. I think that is now the answer to the question that can machine learn from experiences and past data like human being does? Yeah, it can. So I have a good image here. Let's just try to analyze what we have here. So on this side we have a human being, and on the other side we have a machine. And the human being is saying that I can learn everything automatically from experiences. Can you learn? That one is a question that is posing on the machine learning. And the machine says yes, I can also learn from past data with the help of now the machine learning. So basically now machine learning Let's see. Let's see the introduction part of machine learning. We see what it is, and we are saying that machine learning is a subset of AI, what people call AI, artificial intelligence. So in AI, we have now things like the machine learning, we have things like the deep learning. There are so many things in AI, that is artificial intelligence. It's a general term that have so many things. That is not including the machine learning and deep learning. So, and we are saying that machine learning is uh, a subset of AI known as machine learning. We are saying that it focuses primarily on creation of algorithms that enable a computer to independently learn from data and previous experiences. I think you had me mention of forecasting. So you can only forecast if you have enough data. Otherwise, you will be forecasting the wrong things. But if you have enough data, machine now learning can help you to do some of these forecasting. And we are saying that Arthur Samuel first used the term machine learning in 1959. There is, of course, the history behind the machine learning. So we are talking of without being explicitly programmed, machine learning enables a machine to automatically learn from data, improve performance from experiences, and predict things, or what we call now for forecasting, right? You can forecast on sale based on what you have been selling, right? Without now like you see you see the ADA process that you are going through. Each and every time that we want an output, we were passing a certain instruction to we were passing a certain instruction, an instruction to find the maximum, maybe the maximum value in a certain column, passing an instruction to get the minimum value in a certain column. That one is now an explicit programming. For any instruction you give, you're expecting an output. But now we can have areas now in machine learning that now you just have like to create a model. You create a model, you train that model, and then now from that trained model, you're going to see what are models. When you train that model on a certain maybe data set, it's able to do a number of things. It could be a model to predict future. That is maybe future sales. So anytime you just pass new data set to that model, it is able to predict based on what it knows. So that is basically that. The machine learning, you don't in machine learning we don't have an explicit uh, programming. So we are talking of machine learning algorithm create a mathematical model that without being explicitly programmed aids in making predictions or decisions with the assistance of sample historical data, or what now we are calling in these the training data. We are going to see all that. Um, so let's see how a machine learning works, and we are going to have a case here. Let's say we have a complex problem in which we need to make a prediction. So instead of writing our code, we just need to feed the data to generic algorithm, in this case what we are calling a model, which now build the logic based on the data and predict the output. So you might be wondering how now the how now these how now this machine learning is able build the logic based on data. We are going to see how that happens. And you are seeing that our perspective on the issue has changed as a result of machine learning. So the machine learning algorithms operation is depicted in the diagram below. So let's have a look of these diagram here that will enable us to understand how these models work. And the first thing that we always do is to pass an input. We are inputting past data. Let's say we have sales data set. So we input these data to a machine learning algorithm or a machine learning model. So we pass that past data to this model, and what this model will do, it will now train. It will train on it. It will train based on these data. It will try to derive some insights from this data. So like let's say where maybe let's say we maybe for example, can I give here? Let's say maybe we want to predict the sale of maybe the sale of maybe let's say we want to predict the sale of fuel maybe in 5-10 years to come. Of course, you understand that the factors that will influence the cost of fuel, there are so many, right? So, and now if you were to pass those maybe a number of factors that influences the cost of fuel to this machine learning model, it is able to learn those factors. And maybe if you are going maybe to pass like maybe let's say we pass like 10 factors, and each factor we are having maybe that maybe each factor has a data of maybe 1,000 rows of data. So it is able to learn. It is able to learn on that from that data, and even now from now a trained model. In fact, when that model learns from that data set, we call it a trained model. So after it learns from all that data, it is able now to predict. We're able to predict the future, the future cost of the fuel, because we are going to have factor A, factor B, factor C. Maybe when we have a factor A affecting the price with maybe 10%, the other one affect with 5%, the other one with 2%, up to the 10th factor, and we get maybe the price maybe is 170. We learn from now the second row of data, the third up to the 1,000 rows of data. So now from that it is able to you can easily now the model will help you to predict to predict the price of the fuel of the price of fuel in future. So that is basically what happens at this stage. Then I think I've already now talked of learning from data. We build the logical models, and then from there, this now is the trained model, of course with the logical inferences. So this one is a trained model now. So what now we does with this trained model, we are going to pass now we are going to pass new data that this model has not learned from. We call it the test data set. So when we pass the new data set here, we should be able to get an output now from to get an output, because this one is a train. In fact, think of how you think of how you read for exam, right? Maybe you are you are doing some differential calculus. You revise on the differential calculus, and then you have brought some questions to answer. They might be questions on from the area that you have covered, or maybe from an area that needs you to reason. Maybe what we call now the application of the skills, the concepts that you have learned from that. So when you get that exam, of course now you can take that exam as the new data. You are going to provide an answer sheet that is now the output of what it is you have been revising for. So you can relate that now to how the general performance of the model. I don't think I think you are we together, by the way, or I'm just talking my things here. Are we together? The thumbs up if you guys are understanding what we are talking about here. Okay, good. Yeah, basically that is that with the model with the machine learning model. And in fact, now we have features. It's good to check the features of machine learning. And one of the features of the machine learning uh, is that machine learning uses data to detect various patterns in a given data set. I think we have already seen that. The other feature is that it can learn from past data and improve automatically. We are going to, although we are not going like to cover all that within the 4 days that you are going to be learning to be implementing this machine learning, but we have even models that can improve with time, meaning they have memory. In fact, they act like human being. They have memory. What they learn, they store, and they can improve on that. When you continue passing data to train. I mean, when you continue training them with the data. So the other feature is that it is a data-driven technology. Of course, we have already seen that. And machine learning is much similar to data mining, as it does deal with huge amounts of data. These are just but a few features of machine learning. You can try and research, do an extensive research on the features of machine learning. So let's check the need of machine learning. By the way, why do we need machine learning? Think of the data set that we recently worked with that had around 19,230 something rows of data. Assume we didn't have tools such as Python. How long could it take you to learn anything, or even maybe draw an insight from that data set as a human? It can take you years, right? Because going through a data set of 19,000 rows and comparing like 110 rows, I mean columns of data. It might take you ages to draw even a single insight from that data set. So we are saying that the demand for machine learning is steadily rising, and we are saying because it is able to perform tasks that are too complex for a person to directly implement. And that is now why we are needing this machine learning. We are saying that human beings are constrained by inability to manually access vast amount of data, and as a result, we require computer systems, which is where now machine learning comes in to simplify our lives. Of course, human being we might be. Of course, we have the inability to work with large data sets. as I've already given you a case where you are dealing with maybe 19,236 rows of data to even do maybe prediction. That one can that one can make you mad. I'm sure. So we are saying that by providing them with large amount of data and allowing them to automatically expose the data, build model and predict the required output, you can train machine learning algorithms. And we are saying that the cost function can be used to determine the amount of data and the machine learning algorithms performance. So let's see the significance of AI in various fields. And one of the significance of AI is that it can be utilized in various cases, such as self-driving cars. I think these are yet to be brought to Kenya, because I don't think even we have the infrastructure that can support these. But I think in the US we have such self-driving cars, especially now the trucks. These are the long distance trucks. Some of them they have that technology for self-driving cars. So another case that AI can be used is the digital misrepresentation identification. This ones is now when I think by then in your phones you must have. I think you have the biometrics. That is, either you have you can unlock your phone using the fingerprints, right? In most phones we have that. Others have the capability of the face detection. It can easily unlock using a face detection technology, right? I think there is a time I did a project on face record. It was in fact it was a project on the class attendance through face recognition. So again, through now the ML, the machine learning models, there is the companion idea by Facebook. I think you can just try and figure out what is the companion idea by Facebook. It's around how Facebook recommend you some friends, right? You can see you can see just try to research on this, the companion idea by Facebook. I think it is an interesting implementation of or a case where AI is used. It's working well. So I think after this, let's just check on. Because of time, I would like us to check the classifications. I'll also share this document with you so that you can go through it. So I would like us just to go through the classifications of machine learning. We go through the classification. In fact, we have 3 classifications of the machine learning, and we have supervised, unsupervised, and reinforcement learning. So in fact, they are classified or categorized based on how they learn. So we have the supervised, unsupervised, and reinforcement learning. But yeah, let's jump into what is supervised machine learning. And in these classifications, we are just going to check the models that are used in each case. so that you guys, you can understand what you can just have an understanding of what you are going to be covering next week. So we are going to start with the supervised machine learning. And we are seeing that in supervised machine learning, sample labeled data are provided to the machine learning system for training. And the system then predicts the output based on the training data. So think of the data set that we had yesterday. Is it yesterday? Yeah, yesterday. That is on data on the FIFA players. Like based on a number of columns of data, you're able maybe to you're able to determine the overall performance of a certain player. That is based on various columns of data. So in this case now, that one is a case where we have this labeled data set, but we are going to see a case. We're going to see a case here. And we are seeing that the system uses the labeled data to build a model that understands the data set. It learns about in fact, the system will use that labeled data just to learn, just to understand the data set, and even predict how each column of data, how each column of data relates with each other. That is why you are checking the relationship between columns. So we are saying then after training and processing are done, we test the model. I think you have already seen this with a sample of data to see if it can accurately predict the output. So let's see how this supervised machine learning works. I think I had an example here of a supervised machine learning. So let's go through this diagram again. We see how it works. So in this case, we are passing to our model labeled data. This is the input raw data, and we have the labels. Like it's kind of we are passing in this case we have images here, and also we have the labels of the images. And you can see that in this data we have a cow image, we have an elephant, and we have a camel image. So we are passing these images to our model here, to our algorithm, what we are calling the model. So, and also we are passing the labels. So what this machine learning model will do, it will just know that whenever I see an image of this kind, like this one, it will definitely know that it's a cow, because now we are trying to train this model to know that this image represents a cow. But some of us might be asking, how do these algorithms know that this diagram is a cow? Of course, there is now the pixel part. You know, like a certain representation of pixels will have these. It is of this image, and then passing a label to passing a label of that cow. Of course, you understand the computer do not understand this kind of raw data. It must be converted to a format that an algorithm can learn, and that is now learning about the pixels. Maybe you can maybe say that the shaded pixels, you can give them one, and unshaded pixel, you can give them a 0. So in that case, now the model will understand that. So after now giving this data set and the labels, we train the model. So, and the aim of these exercises too is for our algorithm to differentiate between a cow, an elephant, and a camel. So after training this model, uh, we we are going to pass unlabeled data just to confirm that our model is able to determine the images of an elephant, a camel, and a cow. Isn't that interesting? Guys, are we getting this? Yeah, you can imagine a case where you can give a model just giving a model a data set like this one, a data set that is full of cow images, and just pass the labels to that, and you train that model, and now when you give it unlabeled data, it is able to predict that these images of an elephant, these images of a camel, uh, and this image is of a cow. We are going to see cases where you can predict the house price based on various factors. So those are some of the things that we are going to learn. Any question on how supervised machine learning works? Any question? Any question? Okay, thumbs up if you're together. I see Lynn, I can see Amos, I can see Sylvia, Grace. I can see most of us are understanding how these supervised machine learning model works. So now we can get into let's see when now we get into supervised machine learning, it's grouped further into two categories of algorithms. And in this case, we have something we call classification and classification and regression. Let's see that. Yeah, it's divided into classification and regression. So in each case here, we have algorithms that works at each case. So, and we are saying that classifications involves predicting a categorical output variable or a class label. We are saying the goal is to learn a decision boundary that separate different classes. I think we have already seen that with the model that was learning to classify images based on the yes, I think that is it. Um, this model here, where we are determining these images of a cow based on the features, based on the features each image has. That one, in fact, that one is a perfect example of a classification algorithm. So in this case, we are saying the examples of classification tasks include the spam detection. I don't know if you guys you have ever think around how Gmail determine that this email is a legit email and this one is a spam. Again, that one is a perfect implementation of a classification algorithm. That is a supervised machine learning algorithm. That is to determine that this email is a legit email and this one is a spam. The other one is on image classification. I think you have already seen that, and also the sentiment analysis. Some of the algorithms that you can use here, it's what we call we have a logistic regression, we have the k nearest neighbors, we call it KNN, and we have the support vector machines, we call it SVM, and we have another one that is popular called decision tree. We have others such as random forest, and we have the other one that we call the JBM. That is the gradient boosting machine learning model. And then the giant here is always the neural networks. So next week we are going to be covering how you can use the linear regression to do classification. We are going to have a classification problem, and then I think we're also going to check how you can implement. How you can implement KNN algorithm. Then you guys, you're going to, on your own, you can do again an extensive research on the rest of the algorithms. So I think that's all on the classification. And now when you come to regression, now this one involves predicting a continuous output variable. And the goal here is to learn a mapping from input variable to a continuous target variable. An example of a regression task includes predicting a house price. Also, we are going to have a model. We are going to create a model that will enable us to predict the house prices based on various factors. So we have also predicting the stock prices and also predicting temperatures. Some of the algorithms that are used here is also the linear regression. We have the polynomial regression. And then we have others such as the ridge, we have the lasso, support vector. These things, they shouldn't worry you. In fact, you just have to learn one algorithm here, or maybe two in each case, and then you will be good to go. You don't have like to understand each and every algorithms here to be a machine learning guru. So that is the categories we have in the supervised machine learning. You can get to the unsupervised machine learning, and in fact, unsupervised machine learning is the opposite of supervised machine learning. Because in unsupervised machine learning method, or is a learning method in which machine learns without any supervision. And without any supervision, we just mean that you are not going to pass labeled data. So meaning that the model will just try to categorize the past data based on the features. So, and I think we are seeing here that the training is provided to the machine with a set of data that has not been labeled, classified, or categorized, and the algorithm needs to act on that data without any supervision. The goal of unsupervised learning is to restructure the input data. We restructure the input data into new features or a group of objects with similar pattern. So let's just have a look of a picture that I have here, and then you guys, you're going to understand how this unsupervised machine learning works. So you notice that in this case, we are just passing a raw data without labels. You can see we are passing two elephants, and we are passing two camel, and we are passing two cows. So what will happen here when we pass this data to our model here for training? It's going like to categorize these data based on the features. And by features, I mean, of course, we have camel with a long neck, but with the elephant, you know, a long neck is a feature in a camel, right? The legs height. You don't expect the legs of a camel to be of the same size with that of elephant. And the legs of elephant, you don't expect them to be of the same size with that of cow. So based on now these features, we are able to categorize these data. So what now this machine learning model will do is just it will pick an image here. It tries to get the features of each image, and then it will now like categorized all the images with same features. That is like in the case of a camel here, the long neck, the long legs, the hump. These are things that you cannot find in the either in the elephant or the cow. So all the images with such features will be categorized as one. That is what will now happen in this model here. And now you can see after doing all that work, now it is able to give us an output of we have three categories of animals here. We have an elephant, we have a camel, and we have a cow. But the model itself, it doesn't know now this is an elephant, this is a camel, this is a cow, because there is no labels. It is just learn the images through the features they have. That is why we're able just to categorize this based on the features. That is how unsupervised machine learning works. Any question regarding the unsupervised machine learning? Do you have any question? Do you have a question on that? So I think I can proceed to the categories. Again, these are classified into two. We have what we call the clustering and some they call association. And clustering just involve grouping similar data points together based on some similarities or the distance measure. The similarities you can think of now the features. So the goal is to discover inherent groupings or clusters in the data without a prior knowledge of the class labels. I think you have already seen that. I think I've explained that. And some of the common algorithms that are used here is what we call the k-means clustering. And this one that is called the hierarchical clustering. We just have these are the most commonly used algorithms, like the k-means, the hierarchical clustering. The other one is association. I don't think this one is we are going to learn more on this association, but association is a rule learning identifies interesting relationships or association among the variables in large data sets. And the goal here is always to discover the frequent patterns, the association, the correlations. I think you're able to check. I think you guys I showed you how you can check the correlation between data sets, right? Using the core function. So with this association, classification of unsupervised machine learning, the goal is to discover frequent patterns, associations, the correlation among items or variables. In this case, we have an example here is in cases where we have the market basket analysis. This one is mostly used mostly in the supermarket, whereby you just go and pick some items, right? You guys, but then you don't know that you guys, you don't know that you guys, you are monitored. You're monitored when you are doing your shopping. Hmm? You'll always find that, and in fact, this one now influences the way things are arranged in the way things are arranged in supermarket. You don't expect you don't expect that to see in supermarket that you in the shelf that has maybe soap. You don't expect that shelf to have maybe something like maybe sugar or maybe a packet of unga. No, you will find that in a shelf that has maybe those has those what maybe the soaps. You expect maybe to find other detergents. You expect maybe also to find something like what else are you what else do you expect to get in a shelf that has detergents? What else? Or maybe a shelf that has Colgate. You also expect maybe to find toothbrush, right? Because now the toothbrush and uh, and the toothpaste, they are related, or there is that association between those items. So these are the kind of now the algorithms that are used even to determine how things are arranged in a supermarket. Also, you have the recommendation systems and also the anomaly detection. In fact, this one mostly happens during in the cybersecurity area. I think that is that with the application of unsupervised machine learning. And now we have two commonly used algorithms here. That is the a priori algorithm, and we have the FP growth, or what we call the frequent pattern growth algorithms. So those are the two algorithms that you can check how they work. So any question up to that point? Okay, thumbs up if you're together. I think someone has a question. Who is that? You can just unmute and ask. Is it a question? Okay. So those are the two algorithms that, if we have time, we are going to check that. Those two algorithms, that is the a priori and algorithm. But if you want to learn these the machine learning as a course, there at Bounty we have a course that is on machine learning, purely on machine learning. Now that you have you have coding basics. So the other category is, and I don't think I'll touch on these. That is the reinforcement learning. This one mostly happens with robots, and I don't think we are dealing with robots here. In fact, this one it's all about how robots learn. It's all about how robots learn. And even you can see that we are saying that reinforcement learning is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing the action and seeing the results. So in fact, in this case, we for each and every action that the agent does, uh, it, it gets a feedback. It could be a penalty or maybe a positive feedback. So anytime it may be so anytime there is a positive um, so we give a positive feedback when there is a good action that is on the agent, and we give a negative feedback or what we call a penalty when maybe the agent misbehaves in an environment. This one mostly happens when training these machines. That is for example, a robot. And you are saying that reinforcement learning is a type of machine learning method where an intelligent agent, that is a computer program, interact with an environment and it learns to act within it. Think of a robot that is working in a hotel sector. So it must learn on how to interact, on how to work in those hotels, right? Yeah, I think uh, that is enough for today. We have so much in this. There is so much learning on this, but I'll share with you this document. At least you can just go through it. But I can assure you that you are not going to cover these coming next week because it's not something that you are going to use during maybe the analysis. Are we good up to that point? Any question? Suggestion? Do you have any question? Okay, thumbs up if you have learned something today.